This is your boy Isma, and I'm coming back to you with another project that I am working on, and it's currently on Linux Fundamentals Part 1, and we will be embarking on a journey of learning the fundamentals of Linux. We will also be learning to run some of the first essential commands on an interactive terminal. So, starting with Task 1, the introduction. Welcome to the first part of the Linux Fundamentals Room series. You're most likely using a Windows or Mac machine. Both are different in visual design and how they operate. Just like Windows, iOS, and macOS, Linux is just another operating system and one of the most popular in the world, powering smart cars, Android devices, supercomputers, home appliances, enterprise servers, and more. We'll be covering some of the history behind Linux and then eventually starting your journey of being a Linux wizard. This room will have you running your very first commands in an interactive Linux machine in your browser, teaching you some essential commands used to interact with the file system, introduce you to how users and groups work on Linux, and what this means for us as penetration testers. For the answer question below, there is no answer needed. You just click the green button and you're set to go. To Task 2, a bit of background on Linux. It's fair to say that Linux is a lot more intimidating to approach than operating systems, such as Windows. Both variants have their own advantages and disadvantages. For example, Linux is considerably much more lightweight, and you'd be surprised to know that there's a good chance you use Linux in some form or another every day. Linux powers things such as websites that you visit, car entertainment, control panels, point of sale, systems such as checkout tills and registers in shops, critical infrastructures such as traffic lights, controllers, or industrial sensors. Flavors of Linux. The name Linux is actually an umbrella term for multiple OSs that are based on Unix, another operating system. Thanks to Unix being open source, variants of Linux comes in all shapes and sizes, suited best for what the system is being used for. For example, Ubuntu and Debian are some of the more commonplace distributions of Linux because it is so extensible. You can run Ubuntu as a server such as websites and web applications, or as fully fledged desktop. For this series, we're going to be using Ubuntu. Ubuntu server can run on systems with only 512 MB of RAM. Similar to how you have different versions, Windows 7, 8, and 10, there are many different distributions of Linux. Moving on to answer the question below, research what year was the first release of a Linux operating system, and that is 1991. Go ahead and put that answer in there and you're ready to go. Moving on to Task 3, interacting with your first Linux machine in browser. This room has an Ubuntu Linux machine that you can interact with all within your browser while following along with this room's material. However, to get started, simply press the green Start Machine button on the top right of this task indicated by the arrow on the right. Once deployed, a card will appear at the top of the room. Basically what this is talking about right here. This contains all of the information for the machine deployed in this room, including the IP address and expiry timer, along with buttons to manage the machine. Remember to terminate a machine once you are done with the room. More information on this can be found in the tutorial room, which you could press right here. For now, press the Start Machine, where you will be able to interact with your own Linux machine within your browser while following along with this room. For the answer question below, I've deployed my first Linux machine. There's no answer needed, so go ahead and click the green box and move forward. Moving on to Task 4, running your first few commands. One thing that I did forget to tell you on the previous, on Task 3, is you have to go over here to Show Split View so you could interact with your first Linux machine. inside the browser. So we'll get started now. As we previously discussed, a large selling point of using OS such as Ubuntu is how lightweight they can be. This of course doesn't come without its disadvantages, where for example, often there is no graphical user interface or GUIA, or what is also known as a desktop environment that we can use to interact with the machine. Unless it has been installed, a large part of interacting with these systems is using the terminal. The terminal is purely text-based and is intimidating at first. However, if we break down some of the commands after some time, you quickly become familiar with using the terminal. We need to be able to do basic functions like navigate to files, output their contents, and make files. The commands to do so are self-explanatory once you know what they are, of course. And it's just showing you an example right here that this is where you enter your commands. So it'd be right here. We need to be able to do basic functions like navigate to files, output their contents, and make files. The commands to do so are self-explanatory once you know what they are, of course. Let's get started with two of the first commands, which I have broken down in the table below. So our first command, we have echo, output any, so echo, and just like this, echo hello friend. In the description, it outputs any text we provide. So let's give that an example. I'll try it. So we'll try echo hello friend exclamation, and there you go, it outputted this hello friend back. So now we'll try who am I, and this will find out what user we're currently logged in as. So let's see what user I'm currently logged in as, and I'm currently logged in as TryHackMe. See the snippets below for an example of each command being used. So basically what I just showed you. So now we're going to try this on our Linux machine, which we already did. So we're just going to go ahead and move on to answer the questions below. So if we wanted to output the text TryHackMe, what would our commands be? And that's a simple one. It's echo TryHackMe, and we'll just click the green button for the correct answer. Moving on, what is the username of who you're logged in as your deployed Linux machine? And that is TryHackMe. And that concludes this part. Task 5, interacting with the file system. So far we've only covered the echo and who am I command. Not all that useful when you consider things that we need to do, including navigating the file system, read and write to it as well. In this task we're going to be learning the commands so that we can do just that. Just like the previous task, I'll display the commands in the table in the next heading and show examples of these commands being used. Interacting with the file system. As I previously stated, being able to navigate the machine that you are logged into without without relying on a desktop environment is pretty important. After all, what's the point of logging in if we can't go anywhere? And right here we have a box full of commands and their full names. So we have the ls command, which stands for listing, the cd, which stands for change directory, cat for concate, pod for print working directory. So now I'm going to tell y'all what a little bit of each of them even means. Starting with list files in our current directory, ls. Before we can do anything such as finding out contents of any files or folders, we need to know what exists in the first place. This can be done using the ls command, short for listing. And here is an example what they put in inside the terminal. And they typed in ls, and they have important files in there. They have documents, they have notes, and they also have, yes, that's about it. They have screenshots. Anyways, moving forward, great. You can probably take a guess as to what to expect folders to contain given by its name. Pro tip: you can list the contents of a directory without having to navigate to it by using ls in the name of the directory, such as the example ls and pictures. Alright, moving on to changing our current directory or CD. Now that we know what folder exists, we need to use the cd command, short for change directory, to change to that directory. So if I wanted to open the pictures directory, I do cd pictures, where again we want to find out the contents of this pictures directory, and to do so we use ls again. In this case, it looks like there are 4 pictures of dogs. Outputting the contents of file cat. Whilst knowing about the existence of files is great, it's not all that useful unless we're able to view the contents of them. We will come on to discuss some of the tools available to us that allows us to transfer files from one machine to another in a later room, but for now we're going to talk about simply seeing the contents of the text files using a command called cat. Cat is short for concatenating and is fantastic way for us to output the contents of files, not just text files. In the screenshot below, you can see how I have combined the use of ls to list the files within a directory called documents. And here you could tell that example that it is talking to us about. Moving forward, we've applied some of the knowledge from earlier in this task to do the following. Used ls to let us know what files are available in the documents folder of this machine. In this case, it's called todo.txt. Second, we have then used cat todo.txt to concate output the contents of this todo.txt file, where the contents are here's something important for me to delete later, which is talking about right here. Pro tip: you can use cat to output the contents of a file within a directory without having to navigate to it by using cat and name of the directory. And it's showing us right here the example: cat home/ubuntu documents/todo.txt. Sometimes things like usernames, passwords, yes really, flags, or configuration settings are stored within a file where cat can be used to retrieve these. Finding out the full path to our current working directory. You'll notice as you progress through navigating your Linux machine, the name of the directory that you currently working in will be listed in your terminal. It is easy to lose track of where we are on the file system exactly, which is why I want to introduce PWD. This stands for Print Working Directory. Using the example machine from before, we are currently in the documents folder, but where is this exactly on the Linux machine file system? We can find this out by using the pwd command, like within the screenshot below. Now let's break this down. we've already known where documents thanks to our terminal, but at this point, I'm sorry. Okay, so we have. Alright, so I'll just read it again. We're already known where in documents thanks to our terminal, but at this point in time, we have no idea where documents is stored, so we can get back to it easily in the future. I've used pwd or print working directory command to find the full file path of this document folder. We're hopefully told by Linux that this document directory is stored at /home/ubuntu/documents on the machine. Great to know. Now in the future, if we find ourselves in a different location, we can just use cd/home/ubuntu/documents to change our working directories to this document directory. Alright, so that was a little bit of quite the read that we just did. So now moving on to answer the questions below. So as you can see, we have this opened up, and for our first question, it says on the Linux machine that you deployed, how many folders are there? So this right here, you have to use the ls command. So ls as you could see, there's 4 folders total. So you'll put 4 on there and click the green button and you're set to go. Now for which directory contains the file, this is what you're supposed to do. So you type in ls again. So we'll go all the way to folder, for example, folder 2. So it's not on there, so you do the same thing. Do folder 3 now. So no luck with those first 2, but now we're gonna try folder 4 and we should have success. And there you go. Which directory contains a file? That's folder 4. So go ahead and type that in. So now, what is the contents of this file? So for that, we have to use the cd command. So we're going to put cd. So folder 4 / note.txt. Alright, that wasn't it. Sorry about that. So we'll try this again. Sorry about that, it was actually cat. So it's cat folder 4 / note.txt. There you go. So now that's the answer, which we have hello world. So now we'll scroll down and type in hello world and click the green button. For the next question, use the cd command to navigate to this file and find out the new current working directory. What is the path? So this one's pretty simple as well. So we will do cd Now you're just gonna put pwd and here you have your answer. So now all you gotta put in is home/tryhackme/folder4, and you're good to go. I'll just highlight that there. So just go ahead and copy paste that to here, and you should be set to go to the next one. Furthermore, moving on to task 6, searching for files. Although it doesn't seem like it so far, one of the redeeming features of Linux is truly how efficient you can be with it. With that said, you can only be as efficient as you are familiar with it, of course. As you interact with OS such as Ubuntu, over time, essential commands like those we've already covered will start to become muscle memory. One fantastic way to show just how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our users has access to. No need to consistently use cd and ls to find out what is where. Instead, we can use commands such as find to automate things like this for us. This is where Linux starts to become a bit more intimidating to approach, but we'll break this down and ease you into it. Using find. The find command is fantastic in the sense that it can be used both very simply or rather complex depending upon what it is you want to do exactly. However, let's stick to the fundamentals first. Take the snippet before we can see a list of directories available to us. So we have an example right here of the ls command, and we have desktops, documents, pictures, and folder 1 that popped up from that command. Now, of course, directories can contain even more directories within themselves. It becomes a headache when we're having to look through every single one just to try and look for specific files. We can use find to do just this for us. Let's start simple and assume that we already know the name of the file we're looking for, but can't remember where it is exactly. In this case, we're looking for password.txt. If we remember the file, we can simply use find-name.passwords.txt, where the command will look through every folder in our current directory for that specific file, like so. So you have find, you have -name, and you have password.txt. Find has managed to find the file. It turned out it is located in folder 1/passwords.txt. Sweet, but let's say that we don't know the name of the file or want to search for every file that has an extension such as .txt. Find lets us do that too. We can simply use what's known as a wildcard, which is referring to this right here, a star. So search for anything that has .txt at the end. In our case, we want to find every .txt file that is in our current directory. We will construct a command such as find and then the name, which we still don't know, .txt, where find has been able to find every .txt file and has given us the location of each one. So right here, we'll go back to this example. Using find to find any file with the extension of .txt. So you have find the name .txt. So, and this is what it pulled up, folder 1/passwords.txt. You have documents/todo.txt. That was so tough, huh? Which is being a little sarcastic right here. I believe so. Using grep, another great utility that is great want to learn about is Another great utility that is great want to learn about is the use of grep. The grep command allows us to search the contents of files for specific values that we are looking for. Take, for example, the access log of a web server. In this case, the access.log of a web server has 244 entries. Using a command like cat isn't going to cut it too well here. Let's say, for example, we want to search this log file to see the things that a certain user/IP address visited. Looking through 244 entries isn't all that efficient considering we want to find a specific value. We can use grep to search the entire contents of the file for any entry of the value that we are searching for. Going with the example of a web server's access log, we want to see everything that the IP address 81.143.211.90 has visited. Note that this is fictional. Grep searches through files and has shown any entries of what we've provided and that is contained within this log file for the IP. So now we're moving on to the first question, and now I have to show split screen. So for the first question, use grep on access.log to find the flag that has a prefix of the THM. What is the flag? So what we're gonna do right here, we're gonna use grep. So grep THM Sorry about that. So it's actually grep. So then we'll do THM. We'll use the star this time. This again. Access.log. That should do it. And here you have it. We have we have THM access. So just type that in and you should be good. So for the next one, it says I still haven't found what I'm looking for, which we already did, but we'll just go ahead and click this, and that completes this section, guys. Moving on to task 7, an introduction to shell operators. Linux operators are a fantastic way to power up your knowledge of working with Linux. There are a few important operators that are worth noting. We'll cover the basics and break them down accordingly to bite-sized chunks. At an overview, I'm going to be showcasing the following operators, and in this chart we have symbol/operators in the description. So we have the single N. This operator allows you to run commands in the backgrounds of your terminal. Then we have the double N. This operator allows you to combine multiple commands together in one line of your terminal. Moving on to the greater sign. This operator is a redirector, meaning that we can take the output from a command such as using cat to output a file and direct it elsewhere. Now we have the double greater signs. This operator does the same function of the greater sign operator, but appends the output rather than replacing, meaning nothing is overwritten. Let's cover these in a bit more detail. Operator and now I'm going to go over this. Operator single N. The operator allows us to execute commands in the background. For example, let's say we want to copy a larger file. This will obviously take quite a long time and will leave us unavailable to do anything else until the file successfully copies.
The AND shell operator allows us to execute a command and have it run in the background, such as this file copy, allowing us to do other things. The operator double AND. This shell operator is a bit misleading in the sense of how familiar it is to its partner, the single AND. Unlike the AND operator, we can use a double AND to make a list of commands to run. For example, command 1 double AND command 2. However, it's worth noting that command 2 will only run if command 1 was successful. Moving on to the single greater sign operator. This operator is what's known as the output redirector. What this essentially means is that we take the output from a command, we run and send that output to somewhere else. A great example of this is redirecting the output of the echo command that we learn in task 4. Of course, running something such as echo howdy will return howdy back to our terminal. That isn't super useful. What we can do instead is redirect howdy to something such as a new file. Let's say we want to create a file named welcome with the message hey. We can run echo hey single greater sign welcome, where we want to the file created with the contents hey like so. So I will show you an example of what it's talking about. So we're going to type in echo hey, the single greater sign welcome. There we go. Now we're going to do cat welcome. And that's exactly how it's done. No file welcome already exists. The contents will be overwritten just like so. Moving on to the operator double greater than. This operator is also an output redirector like in the previous operator single greater. We discussed, however, what makes this operator different is that rather than overwriting any content within a file, for example, it instead just puts output at the end. Following on with our previous example, where we have the file welcome that has the contents of hey, if we were to use echo to add hello to the file using the single greater operator, the file will now only have hello and not hey. The double greater than operator allows to append the output to the button of the file rather than replacing the contents like so. So I will show you the example. So we have echo double greater than hello. Oh, sorry, I did that wrong. So it's actually hello. Echo hello double greater than welcome. I'm going to put enter. Now we're going to type cat welcome, and we have hey and hello added to it. Moving on to the answer to the questions below. If we want to run a command in the background, what operator would we want? And that's the single AND. Moving on to the next question. If we wanted to replace the contents of file named password with the word password 123, what command would we use? That's simple. So we use echo password one two three space passwords. And that's how you do it. Now, if I wanted to add try-hack-me to the file name password, but also keep passwords 123, what would my command be? So for this one, it's pretty simple as well. We would put echo try hack me the double greater sign, passwords, and we hit enter. And that's the correct answer. Now use the deployed Linux machine to put these into practice. And that concludes this section. So one thing I forgot to mention, for the first one, it would be echo password 123 greater than passwords, and then we would put cat passwords, and then passwords 123 would populate. Now if we wanted to add try hack me in passwords 123, we'd basically put echo try hack me greater than a double greater sign passwords, and then we'd put enter, then we'll put cat passwords, and then as you can see you have password 123, and we added the try hack me as well. Task 8, conclusions and summaries. Nice work on getting to this stage. We covered quite a bit for your first interaction with Linux. However, these are the most essential functions you're going to be using whenever you interact with a Linux machine. I hope this room hasn't been too daunting for you to power on through with. It's as I previously mentioned, you're going to become familiar with these things very quickly because of how often you're going to be using them. To quickly recap, we've covered the following: understanding why Linux is so commonplace today, interacting with your first ever Linux machine, ran some of the fundamental commands, had an introduction to navigating around the file systems and how we can use commands like find and grep to finding the data even more efficient, and lastly, power up your commands by learning about some of the important shell operators. Take some time to have a play around in this room. When you feel a little bit more comfortable, progress onto Linux fundamentals, and basically you'll just move on to the second portion of this lab. But as far as for the answer question below, I'll have a play around and just click complete and you're good to go. On to task 9, Linux Fundamentals Part 2. Visit Part 2 of the Linux Fundamentals series by clicking this link. And moving on to answer the questions below, terminate the machine deployed in this room from task 3. So we'll terminate the machine, click complete. We will now join the Linux Fundamentals Part 2, and we have successfully completed this room.